Okay, so we're moving into section 1.2, and in section 1.2, we're going to take our systems of equations and turn them into matrices. And so matrices, let me get to the right page, and that would be helpful. There we go. So a matrix is made up of just numbers, and it has a certain size, and the size is written M by N, which means that it is going to be row by column. So it's always going to be R by C. Now each entry in a matrix has a label, and that label we did talk about the other day was Aij. So A represents that it's an entry in the matrix, and Ij tells you its position. So for example, if I said, what's in position 2, 3, that would be what element is in row 2, column 3. And so that's what we're going to look for there. And again, the size of the matrix is going to be row by column. They call that M by N. But I always just write it as row by column because that helps me. The plural of matrix is matrices. All right, the first thing that we're going to do with it is we are going to look at the size. Okay, so on your page, it gives you A and B and C, so it shows you something that's 1 by 1 and 2 by 2 and even 2 by 3 with A, B, and C. And so here were my examples on the right side. So with this first one, I have 1, 2, 3 rows and 1, 2, 3, 4 columns. So this one would be a 3 by 4 matrix. So the next one is row 1 with 3 columns. So this is a 1 by 3 matrix. Since it's only made up of just one row, it's also called a row matrix. Okay, this one has 3 rows, but only 1 column. So this is 3 by 1, and it's called a column matrix. Okay, so looking at the objectives from this section, 1.2, I'm going to ask you what's the size of the matrix. I'm also going to ask you, give me a matrix of size 4 by 5. Or give me a matrix that's a column matrix. Give me a matrix that's a row matrix. So I'll ask you those questions. At the bottom of that sheet, it talks about the difference between an augmented matrix and a coefficient matrix. Now, sometimes that's a short answer question that I'll ask you on a test. And the difference is an augmented matrix has the constants, and a coefficient matrix has only the coefficients. Okay, so it shows you this system here. It's written really small on the board, but what they do is they take only the coefficients. So you had a 1 and a -4 and a 3, and a -1 and a 3 and a -1 here, and a 2 and a 0 since there's no y there, and a -4, and that makes an augmented matrix. If you took only the coefficients, you would take the first 3 columns. Now, when I worked these a little later, because my teacher, when I had this at Mississippi State, she put a little bar right there to represent the equals, and so that's how she did those. Now, just to make sure I'm on the right page, we haven't done these yet, right? Okay, perfect. All righty. Let me look back at my notes real fast. We did that one. Okay, so on your little handout, I wrote augmented and coefficient matrix, and that was kind of like just a little note to me, hey, make sure that we cover that. And so as we do a real example in just a little bit, I'll show you that again. The next, you have elementary row operations. Remember that you have 3 operations that you're allowed to do. They're the same ones that we had in section 1.1. I will ask you these on a test as far as a definition. You're allowed to interchange 2 rows, you're allowed to multiply a row by a non-zero constant, and you're allowed to add a multiple of an equation to another equation, or a multiple of a row to another row. Right, so those are important, and that's a short answer that I'll ask you. Now, when we work these matrices down, we're trying to put them in this form called row echelon form. And row echelon form has these properties that you see on the screen. First of all, if it has a solid row of zeros, it has to be at the bottom. For every row that doesn't have a solid row of zeros, the first digit has to be 1. For two rows that are in order, successive, the leading one has to be further to the left. Okay? So trying to picture what it's asking you here. If you have a 1, let me write it again. If you have two rows, let's say you had this row and you had this row. Just writing some random digits up. This one is not in row echelon form, and even though they both start with a 1, so they both start with a 1, so that passes rule 2. But it says if you have two non-zero rows, the top one has to have the 1 to the left. See how this one's to the left? So this one has to be in the top, in which case we would switch rows 1 and 2. Now, that one is in row echelon form. And so that's how that part would look. If it has successive 1s, the top one has to be to the left. It makes this stair-step pattern. So what you're looking for is a 1. If we just took a basic 3 by 3 augmented matrix, this is what we're going for. That's going to be our goal. Now, underneath that 1 and 2 and 3 on your sheet right here, it talks about reduced row echelon form. And reduced row echelon form means that every one has zeros above and below it. Okay? So, for example, this one right here is called row echelon form. If it was reduced row echelon form, the ones would have zeros above and below. Okay? And you'll say, well, what's the number sign? The number sign means that can be any digit. So if it's in row echelon form, it has if it has a solid row of zeros or on the bottom, everything starts with a 1, which it does, and every one that's in the row above it has a 1 to the left. So 1 to the left, 1 to the left, so forth. But if it's in reduced row echelon form, then it has the same properties as that one, except every one has zeros above and below it. Now, leading on to some other kind, we're going to refer to it later on, so I'm just going to get it here because everything's all written well. When you are writing these, when we're solving these down, it's the process of Gaussian elimination. So if you're writing it in row echelon form, that's called Gaussian elimination. But if you're taking it a step further and you're writing it in reduced row echelon form, that adds another guy to the mix, and his name was Jordan. So this is called Gauss-Jordan elimination. So one of the questions I ask you short answer-wise is what's the difference between Gaussian elimination and Gauss-Jordan elimination? And the difference is for Gauss-Jordan elimination, you write it in reduced row echelon form, but for Gaussian elimination, you just write it in row echelon form. And that is the difference. All right, so that's a lot of definition-y stuff. Let's get to some questions. I ask you, are these matrices in row echelon form, reduced row echelon form, or neither? Okay, now you're not going to work with these matrices. You're just going to answer one of the three labels. They're either reduced row echelon form, or neither one. Now, sometimes I'll ask you why. Okay, so let's look at, and everybody has the sheet, right? Okay, I'll let you flip across. It's in your little packet. It's 1, 2, 3, 4, 5, the 6th page. All right, so if I look at this first one, my answer, I'm going to go ahead and do the first one for you. My answer is neither. Okay? Are you with me? Do you know where I am? Okay, just checking. My answer here is neither. And the reason it's neither is to be in row echelon form, every line had to start with a 1, and this one is not a 1. And so that is why it fails. It's not row echelon form. It's certainly not reduced row echelon form. And so that would be neither. Okay, I'm also going to jump to the bottom because it's easier to explain. This one is also neither. What's wrong with it? It has a whole line of zeros. And if it has a solid row of zeros, they must be at the bottom. So that's why that one is not in row echelon form. Now let's look back at the one that says neither at the top. The reason that this one was not is line 2, row 2 rather, let's call it row 2, started with a 2. And that violates row echelon form. All right, so then we have the one in the middle. Now I like to put my equals here. And so if we look at this one, every row started with a 1, great. Above and below every one there was a 0, great. So this one is called reduced row echelon form. And that's how that one would look. All right, so that's your next objective. They're going to ask you for the size. They're going to ask you to give examples of a certain matrix of a certain size. And then they're going to ask you row echelon form, reduced row echelon form, or neither. Mm-hmm. Just the coefficient matrix. That's exactly right. Well, yes and no. In a 3x3, yes. But it could be 4x4 or it could be 2x2, which would not be. Yes. Yes, and you want that main diagonal. You want the main diagonal to have ones. But, that was a very good question, and I had to think about it for a second. This is also reduced row echelon form. And you could even say that is also reduced row echelon form. So we pretty much mine are the tic-tac-toe, just like you said, because that's your basic type. But there are some variations there that are not the tic-tac-toe.
I was wondering if it had to do with something like you're given what X, Y, and Z are, reduced row echelon form, maybe hence its name, simplifying the system of linear equations.
Yes, so when you solve it out, like this particular one right here that's in reduced form, you can immediately see what x and y and z are. And because this would say that x was -1 and y was 2 and z was 4. Yes. All right, so let's work one. We already talked about that. 1, 2, 4. Looking good. All right, so I ask you to solve this, and I ask you to solve it using matrices. All right, so we're going to work this one all the way out. The first thing that we're going to do with it is we are going to first write it as an augmented matrix. So I'm going to have 2, 4, -3, and -18. And 1, 3, 5, 15, and 3, -1, -4, -11. Okay, now as far as working this one out, it's not hard to do, and it's just an arithmetic exercise, right? We're just gonna add and subtract some things and move some things around, and it's you guys do fine with the concept. But what you guys don't do fine with, and this is just based on personal prior experience, is you don't do fine with paying attention to details and making sure you don't make a sign mistake. And that's myself included. And I think I told you this in one of our last lectures, that if I'm going to make a mistake, it's going to be copying wrong. So as soon as I write it as an augmented matrix, I go back and I double check. I'll even double check it on my notes sometimes just to make sure that I didn't copy it wrong. Especially a sign. If I had copied this 1 in the bottom as a positive 1 instead of a -1, I missed it before I ever started it. All right, so, because sometimes I write it down on the notes wrong too, so I'm going to look at my original notes. Okay, I got it. Now, here's what we're going to try to do with it. When you're working this down, we're going to work it in Gaussian elimination. We're not going to go to reduce. We're just going to go to Gaussian. And when you do it Gaussian, it's just like Will said earlier, we want it in tic-tac-toe form. So our first thing that we've got to do is get a 1 there. And after we get a 1 there, we're going to get a 0 here. And after we get that 0, we're going to get a 0 here, and we'll be done with the first column. So that's what we're going to do first, and that's 3 separate steps. A 1, a 0, a 0. And that's the order in which you need to go. After you get those done, you're going to go to your next column, and in your next column, you're going to get a 1 here and a 0 here. I'm not worried about this digit here, so it can stay alone. And that's going to be my next column, so I'll do the blue part. And then I'll go to my third column. So I need a 1 right here. You always get your 1 first. And then I don't care about these numbers. And then we can back substitute. This is my goal. If I'm using Gaussian elimination, that means I want to put it in this form, which is called row echelon form. Now, if you wanted to do it a little bit more detailed and go straight to the answer where you don't have to do back substitution, you could also get rid of the 3 pound signs that are on the left. Right, so that is our plan. Now, when we get ready to do this plan, there's more than one way to get it. So, for example, I'm going to get a 1 in the top by interchanging rows 1 and 2. Some of you might have gotten a 1 in the top by saying, -1 row 1 plus row 3 gives me a new row 1. You can also do it that way. Some of you might have said, I'm going to say 1/2 row 1 gives me a new row 1. All of those would be great. I think I described it the other day, like if we were trying to get to Chick-fil-A, I might take my car, Joseph might walk, Will might go around by Tate Hall first. We all get there. It's just a different way to get there, and that's perfectly fine. All right, so here we go. Let's do this. The first thing that I'm going to do to get a 1 in the top is I'm going to interchange rows 1 and 2. Just swap their places. the other thing that I'll say is some of you might do more than one step at a time. Perfectly fine. All right, as always, I'm going to double check, make sure I copied it right. I did. Do you have any questions with step 1? Okay, the next thing I want to do is I want to get rid of this guy right here. So to get rid of a 2, I need a negative 2, right? So I'm going to take that 1 in the top, and I'm going to multiply it by negative 2. I'm going to add it to row 2, and remember that's going to give me a new row 2. So row 2 is what I'm going to want to change. Now, just where you see where we're going with it, I'm not going to change row 1. I'm going to use it. I'm going to use it to find a new row 2, and I'm going to use it to find a new row 3, but I'm not actually changing row 1. Row 1's going to stay the same. So here's how it looks. Some of you can do it in your head. I don't do anything in my head. So I've got to take negative 2, and I'm going to multiply all the way through row 1. So that's going to be a negative 2, a negative 6, a negative 10, and a negative 30. So I'm going to say negative 2 all the way across. Negative 2, negative 6, negative 10, negative 30. I'm going to add that to row 2. And that gives me a 0, a negative 2, a negative 13, and a negative 48. And that's what I get. Okay, so remember my goal was to get a 0 here, which I've done, and that's what I'm trying to do. Are there any questions to that piece? Okay, so now we're going to get rid of the 3. Okay, so to get rid of this 3 right here, I'm going to go back to row 1, and I'm going to say negative 3, row 1, plus row 3 gives me a new row 3. So multiplying the top row by negative 3, negative 9, negative 15, negative 45, I'm going to add that to my row 3. That gives me a 0, a negative 10, a negative 19, and a negative 56. And I have successfully completed my first column, which is what I was trying to do so far. Are there any questions with the first column? Now, we move to the second column, and it's normally customary to get a 1 first. Okay, so I would turn that 2, negative 2 rather, into a 1, so I can do that, which is what I'm going to do. But some of you might say, couldn't I just multiply it by a negative 5 and that's going to get rid of the 10? You could. That way works fine too. Yes, you could certainly do that. All right, so now then, we're going to go to our next little level. Are there any questions with the blue or the pink so far? All right, so now then, I'm going to get that 2 to become, because I'm going to go in the order, I'm going to go in their recommended order, just where I'll try to stay consistent when I'm working it. So if I'm going in their recommended order, in order to turn this 2 right here into a 1, I'm going to say negative 1/2 row 2 gives me a new row 2. Row 1 stays the same. Row 3 stays the same. And I'm going to get a new row 2. I'm going to double check my signs. So I'm multiplying by a negative 1/2. So multiplying by a negative would make a positive, positive, positive. So I double check that. In matrix operations, we don't divide. So we multiply by a fraction, which is the same thing as dividing. So that's a hint as well. And the other hint that I'll tell you is not all the time, but most of the time when you're looking for a 1, you're going to use the operation where you multiply a row by a constant. So if I'm trying to turn this 2 into a 1, I'm going to multiply that row by 1/2. So usually to turn a row into a 1, or turn a value into a 1, you multiply by a constant. Usually to get a 0, like we did here on this first column over here, to get a 0, that's when you add 2 rows together. All right, so now then I'm going to try to get rid of this 10. So to get rid of this 10, I'm going to say, let's pick a different color. Let's go red this time. I'm going to say 10 row 2 plus row 3 is going to give me a new row 3. Okay, that means row 1 and 2 are going to stay the same. Okay, and I need a new row 3. So I'm going to multiply row 2 by 10. I'm going to double check my numbers. So 10 times that would be 130 over 2, which is 65. So I think I like it. Okay, so that's going to give me a 0 and a 0. And that's a 6, 46. And this is 10, 8, 184, I believe. Okay.
And it does help that I've kind of gone through these 5 problems without knowing how to do Gauss-Jordan elimination.
Okay. Uh-oh. Sorry, everybody on the video.
That's why I was able to think of multiplying negative 5. I think you forgot to put the carry there between 1 and 2. We can always say that.
Here?
Yeah, 2.
Oops.
On the right.
Over here? I didn't change it. So the question was, why is that not a 240? So I multiplied 10 by this row, right? But I only changed row 3. So this right here had to stay just like this.
Oh, that's your answer.
Yes. Does that make sense?
Yep.
And I know the rule, it's all jumbled up. That's why I'm going to that next page. There it is. Okay, make sure I'm on there. Okay. I ran out of room. I saved it though, don't worry. It's saved. Okay, now. Whoops. Now then. Okay, so these problems take a long time, as you see, right? So when I get to this one, it is not in row echelon form. And it's not in row echelon form because of that 46. So what I'm going to do at this point is go to the third column, right? And I'm going to say 146th row 3 gives me a new row 3. Row 1 stays the same. Row 2 stays the same. And row 3 is 0, 0, 1. And what?
I took 184 divided by 46 and not
4. Perfect. And now it's in row echelon form. That's not my answer, but now it is in row echelon form. So what we do now that it's in row echelon form is we're going to backtrack and back substitute and find our values. Do you have any questions getting it to that form? All right, so here's where I put my x's back in. So this top line is actually x plus 3y plus 5z equals 15. And my middle row is y plus 13 halves z equals 24. And my bottom row is z equals 4. Because remember, it's A and B and C in those columns. Sorry, it is that. But it's x and y and z in those columns. Right, so now we'll back substitute. So z is 4, so let's go to the one above it. So this is y plus 13 halves times 4 equals 24. Okay, so that's going to be a 26. I'm going to subtract 26 from both sides, and y would equal a negative 2. So there's one piece. There's the other piece. So now we have to go back and get x. So x is x plus 3 times y plus 5 times z equals 15. X plus 3 times y plus 5 times 4 equals 15. Okay, so this is x minus 6 plus 20 equals 15. So this is x plus 14 equals 15. So I subtract 14 for both sides, and x would equal 1. Now, I give you full credit for writing it like that. That's fine with me. But technically, it's an ordered triple. And so an ordered triple, you have to write in order, though. So an ordered triple would be 1, negative 2, 4. And that's how it would look. And again, that's called Gaussian elimination. Any questions with it?
I didn't know what Gauss-Jordan elimination was. Whenever I was in the choosing that, I was assuming maybe it was algebra. Is it the case it's just done for practice for this practice exam to use Gaussian elimination on this one of the problems, or is that also going to have to be done with the test?
On the test, I don't make you, I make you use Gaussian, yes. I don't make you use Gauss-Jordan. We just hadn't gotten there yet. So if you'll hold on just a second, let me explain this next slide, and then I'll go. I think it's going to answer your question. All right, so on this one, I ask you Gauss versus Gauss-Jordan. It should be in your sheet. Let me get your packet and see. Yep, Gauss versus Gauss-Jordan. So when we work this one, so some of you might want to work ahead and work it, and that's perfectly fine to do. But when we get this one, this is what we're going to start class with on Wednesday. Now, if you'll notice this x right here, there's not an x. So this one right here is going to be 0x. So when you set up your matrix, don't forget to put a 0 there. But when we work this one next time, we're going to work it in Gauss-Jordan form. So Gauss-Jordan form means that we're going to find a 1 and then 0 and 0. And then we're going to find a 1 and then 0 and 0. And then we're going to find a 1 and then 0 and 0. And when you do it this way, so we'll do exactly what we just did on the previous slide, except we'll go back and find this one and this one and this one the same way. And when we do that, you're going to find x and y and z by inspection. Now, I gave you that worksheet the other day, which was just where you could start practicing, but unfortunately, I guess I gave it to you a little early because I hadn't covered the concepts yet. So normally I hand you a packet out and, you have that packet to do, but I gave it to you too early, so I apologize for that. I'll hold on to them next time. But we haven't gotten to the Gauss-Jordan part yet, but that's what we're going to do next time. All right, so we'll have 1, 2, 3 left to do next time. So let's talk about a test for a second. So on Wednesday, we're going to finish the material. On Monday, it's a holiday.
Oh, is that one Labor Day?
Yep. On Wednesday, we'll review. And then your test is the following Monday. So I don't know what day this one is. I don't have my dates. But 2 weeks from today, you're going to have your test. All right. So I'm going to give you, do you have a date? The 8th. Right, here is your next hybrid assignment. And so this will be due next Wednesday, because it'll be due Wednesday. Okay, so write that on the top. Normally they're due Monday, but that's a holiday. So this is going to be due Wednesday. All right, Will, tell me what day Wednesday is. The 3rd? Yes, okay. So that hybrid assignment is going, oh, I can't abbreviate it like that, sorry. The hybrid assignment is going to be due on the 3rd. Okay, so we got that. Now, if you want to practice, if you want some extra practice, these are for practice only. Here are the suggested problems that are from the textbook. Now, if you look in the e-book, you'll have to find out where that section is. But the one great thing that I noticed about the e-book is, let's say that you did want to practice 1.1 number 41. If you click on it in the e-book, it's going to give you the answer. So all of those answers are going to be easily accessible. And again, this is just for extra practice. If you need extra practice, then do them. If you don't need extra practice, that's fine too. Remember that I haven't covered all the material yet, so we're still in that process. All right, on your weekly assignment, it says weekly assignment number 2, we have not talked about homogeneous systems yet, so we haven't done number 2. We briefly talked about number 3, but I'd also wait on that. We did the rest of that page. Augmented and coefficient. Let me go back a slide for a second. So this particular one that we worked here, this part, this right here, I should have mentioned it, but this red piece right here is the augmented matrix. And this is the coefficient matrix. Now, eventually, we're going to talk really heavily about coefficient matrices and talk about something called the determinant, and that's when we're going to specifically use the coefficient matrices. But for this test, we're going to use augmented. So that's the difference in an augmented and a coefficient matrix. And then you have your systems, 9, 10, 11, 12, 13, and 14. Okay, 13, I'll go ahead and tell you. 13 is infinitely many, so we're going to practice writing that one with a parameter. And 14 is no solution. So it's also a special case. So don't work 13 and 14 yet. 12 you can work. 10 is also a parameter. So 10 and 13 and 14, just know that those are going to be special cases if you want to wait on them.